Welcome to our exploration of David Hilbert, a figure often described as the architect of modern mathematics. Born in 1862, Hilbert's influence spans nearly every corner of the field, from his rigor in geometry to the creation of Hilbert spaces in functional analysis. Perhaps his most enduring legacy is the list of 23 unsolved problems he presented in 1900, which set the research agenda for the entire 20th century. Today, we'll dive into his life and the profound ways his quest for a logical foundation forever changed how we understand mathematical truth. David Hilbert was truly the man who mapped the infinite. In algebra, he revolutionized invariant theory using abstract existence proofs. In geometry, he provided a flawless axiomatic foundation for Euclidean principles. His reach extended to physics, where he co-discovered the mathematical framework for general relativity and influenced quantum mechanics. Finally, by posing 23 problems, he charted the course for 20th century mathematics. Hilbert's genius wasn't just in solving problems, but in defining the very language of modern science. Hilbert's journey began in Königsberg, though he famously described his early language-focused schooling by saying, "I was a dull and silly boy." His potential finally flourished after transferring to the science-oriented Wilhelm Gymnasium in 1879. By the time he entered the University of Königsberg in 1880, he was ready to reshape the field. It was here that he formed a lifelong intellectual triad with Hermann Minkowski and Adolf Hurwitz, a collaboration that fundamentally shaped his legendary mathematical trajectory. In 1888, Hilbert revolutionized invariant theory. While Paul Gordon had previously solved the finiteness theorem for binary forms through massive, complex calculations, Hilbert took a different path. He proved the object's existence abstractly using the law of excluded middle, without calculating it at all. Gordon was so stunned by this departure from traditional methods that he famously declared, "This is not mathematics. This is theology." Though initially rejected, the paper was eventually accepted, leading Gordon to concede that even theology has its merits. In 1899, Hilbert published Grundlagen der Geometrie, proposing 21 new axioms to replace Euclid's traditional set. His core philosophy was that geometry should not rely on physical intuition or reality. He famously argued that as long as the logical relationships remain consistent, the undefined concepts of points, lines, and planes could be replaced by anything, even tables, chairs, and beer mugs. By decoupling mathematics from the physical world, Hilbert established a purely formalist approach that redefined the very foundations of the discipline. On August 8, 1900, at the Second International Congress of Mathematicians in Paris, Hilbert delivered a mandate that would define an era. He posed a fundamental question. Who of us would not be glad to lift the veil behind which the future lies hidden? Believing that the vitality of any science is measured by its abundance of unsolved problems, he provided a programmatic overview of research. This presentation introduced his legendary problems, effectively charting the course for mathematical discovery throughout the 20th century. Solving a Hilbert problem became the ultimate badge of mathematical immortality. Among his 23 challenges, 3 stand out for their profound impact. Problem 1. The continuum hypothesis, seeking the cardinal number of the continuum. Problem 2. Arithmetical axioms. The quest to prove mathematics is entirely free from contradictions. Problem 8. Riemann hypothesis and Goldbach's conjecture, investigating the deep mysteries of prime distribution. While many have been conquered, several remain the greatest intellectual hurdles of our time, continuing to shape the legacy of modern mathematics. In 1895, Hilbert was appointed to the chair of mathematics at the University of Göttingen, transforming it into the world's mathematical mecca. His influence was unparalleled. He served as editor of mathematician, the era's leading journal, and guided 69 PhD students. His network of brilliance included legendary figures like Hermann Weyl, John von Neumann, and even chess champion Emanuel Lasker. Together, they formed an intellectual powerhouse that shaped global research priorities for decades. In 1909, while investigating integral equations, Hilbert introduced the revolutionary concept of infinite-dimensional Euclidean space. Though conceived as purely abstract mathematics, these Hilbert spaces eventually provided the essential mathematical framework for quantum mechanics. The physical significance was solidified in 1926, when John von Neumann proved that quantum states are perfectly understood as vectors within a Hilbert space. This transition from abstract theory to the bedrock of modern physics perfectly illustrates the unforeseen power of Hilbert's mathematical vision. By 1912, Hilbert pivoted his focus almost exclusively toward the world of physics. This shift reached a climax in the summer of 1915, when he invited Albert Einstein to Göttingen for an intensive week of lectures on gravity. This intellectual catalyst spurred a high-stakes race. On November 20th, 1915, Hilbert submitted his axiomatic derivation of the field equations, now known as the Einstein-Hilbert action. Just 5 days later, Einstein submitted the conclusive field equations, forever linking these two giants in the discovery of general relativity. In a moment that could have sparked a legendary priority dispute, David Hilbert displayed a remarkable masterclass in grace. Despite submitting his axiomatic derivation of the field equations 5 days before Albert Einstein, Hilbert gracefully conceded priority. He famously quipped that every schoolboy in Göttingen understood four-dimensional geometry better than Einstein, yet credited Einstein alone with doing the actual work of the physical theory. By doing so, he prevented a lifelong feud and ensured the focus remained on the monumental achievement of general relativity. In the 1920s, Hilbert launched a monumental movement to ground all mathematics on a solid, complete, logical foundation. His goal was to prove that every mathematical truth follows from a correctly chosen finite system of axioms, and that these axioms are entirely consistent. At the heart of his philosophy was a rejection of the ignorabimus, the idea that some truths are forever unknowable. To Hilbert, mathematics was an autonomous system of internal necessity, where every problem had a solution waiting to be found. In September 1930, during a meeting in Königsberg, Hilbert delivered a stirring address radiating ultimate mathematical optimism. However, the foundation of his program had already begun to shift. Just 1 day prior, a young Kurt Gödel tentatively announced his first incompleteness theorem. Gödel proved that any sufficiently complex axiomatic system will contain true statements that cannot be proven within that system. This landmark proof revealed that Hilbert's dream of a perfectly complete and consistent mathematical framework was, unfortunately, impossible. The tragedy of Hilbert's final years was the destruction of his beloved Göttingen. Following the Nazi rise to power in 1933, a ruthless purge dismissed Jewish scientists, gutting the world's premier mathematical institute. The devastating impact was captured in a 1934 exchange with the Nazi Minister of Education. When asked if the institute had suffered from the departure of the Jews, Hilbert delivered a chillingly honest verdict. Suffered? No, it hasn't suffered, Mr. Minister. It simply doesn't exist anymore. David Hilbert passed away on February 14, 1943. Though his funeral was small, attended by fewer than a dozen people, his intellectual footprint remains immense. His tools, mathematical spaces, and legendary problems continue to define the very architecture of modern mathematics and physics. His ultimate, unwavering response to the limits of human understanding is immortalized on his tombstone. We must know. We shall know. This epitaph serves as a permanent reminder of Hilbert's lifelong commitment to the pursuit of absolute mathematical truth. David Hilbert didn't just solve mathematical problems. He redefined the very language of the discipline. This timeline traces his journey from the foundations in Königsberg to his era of global influence. Early in his career, Hilbert revolutionized invariant theory. In 1888, he solved Gordon's problem by proving the finiteness theorem. Instead of a long calculation, he used an abstract existence proof, a move so bold his peers initially called it theology, not mathematics. By 1895, Hilbert moved to Göttingen, transforming it into the world's mathematical capital. He published Foundations of Geometry, providing the first rigorous axiomatic framework for the field since Euclid. The turning point came in 1900. At the Paris International Congress, Hilbert presented 23 unsolved problems. These challenges became the North Star for 20th century research. His later work on Hilbert spaces laid the groundwork for functional analysis and even general relativity. He concluded his career with a defiant optimism, famously declaring, "We must know, we shall know." Even as the Nazi regime purged his beloved Göttingen, Hilbert's legacy remained an unshakable foundation for the modern age.